All right. Yeah, so I got the labels to face the screen all the time. So that's cool. What I'm gonna be trying to do now is probably just rotate this, show how this interacts with the view matrix. What I think would be really nice is if I could see one view in which I see a camera moving through 3D space, and then a second view where I see the scene from the viewpoint of that camera. And I think setting that up will require... Well, actually... Yeah, and I think setting that up is going to require having multiple cameras, so to speak. So if I can start by doing some sort of ambient rotation, where I just move the camera around like that. That'd be the first step. Then I want a second view where I have a fixed view, maybe like this. And where I can see that camera moving in space. And that'd be really helpful for visualizing the way this is going on. So let's try that. I'm pretty sure I can add updaters to that camera. Well, maybe not, because the camera I don't think is added to the scene. I actually don't know where I would add that. I could just do it in the updater for one of the mobjects. No, that seems kind of wrong. It should be possible to add updaters just to the scene itself. Let's see. So this is where it updates mobjects. Okay, so here's where it updates mobjects and meshes during the interact. Okay, and then it'll do it in update to time. So maybe I should just... Aquabeam, what's going on? What I should maybe do is have something like self.like-update self, something like that. And then have a list of updaters that are added to the scene. But I don't think that'd be super hard to do even. Just figure out spherical coordinates. I did. But it's kind of a misleading thing to say, because what made this difficult wasn't spherical coordinates necessarily. What made this difficult was that the geometry involved was pretty insane. But it all fits into... Well, it doesn't fit that well. There, that's the entire function. But the geometry was really crazy. But I did it. What made it crazy? Well, it was like the way you have to think about it. Well, here, I think I can use my tablet now. So let's try to do that. Thanks. So it's hard to even draw. Like, here's a camera. Oh. Here's a camera. and it's looking at something. I'll say it's looking at the origin because that's where it's usually directed. And there's also a letter somewhere. And from the camera's perspective, I want the bottom of this letter. And this letter is holding a vector that's supposed to point down. The bottom of that vector should align with this vector. Where if I take a vector from the origin to the camera, and I basically rotate that 90 degrees, this is where I want the down vector on this letter to align. However, this vector exists in a plane defined by this vector from the origin to the camera, and the letter's down vector exists relative to a different plane from the object to a camera. That's not a very straight line. It exists within a different plane entirely. So then the question becomes, how can you align this vector to this vector if these vectors are in different planes? And the way you have to do that is that you have to project this vector onto the plane defined by this vector. And that'll give you some projection. Okay, this isn't the best picture, but that'll give you some projected vector, like possibly that. Then you have to... Wait, no, it's the other way around. I'm already getting it wrong. Wait, no, it's not. That's the way it is. You project this vector onto this plane. That'll get you a projected vector. Then you rotate this vector to line up with that vector in this plane, and then it works. I hope that all made sense. But like, the key thing that made it really hard was realizing that these two vectors, the camera's down vector and the object's down vector, can never be aligned, or not in general. So there was nothing you could do without projecting one of them. And so that caused a lot of confusion trying to solve it. I figured it out. All by myself. Okay, so update self. If I go to update meshes here, I'm just gonna make up an update self. I'm gonna say for function and self.updaters, I just call func. And self.updaters doesn't exist. So I'm just gonna add that in here. Where's self.mobjects? Here, where's self.meshes? Oh, it's there. And self.widgets. I'll just put it here. So now there's a self.updaters. Then I'm just going to call update self wherever I call update meshes. I think there's another place. Oh, update to time, update objects, update meshes, update self, and then here and interact. Okay, so that's both. And then what I'm gonna do is self dot add updater, which I'll have to also write that. Maybe just right after remove. Although I'm not huge on even doing this function because it doesn't do that much. But now that I think of it, you'll want something like a remove updater too. And actually, how do I even compare functions? Restructured mobject list. I think this should basically be a list comprehension. Self.updaters equals the list of f for f in self.updaters if f is not func. I think that should work. Then hopefully I can add an updater, and I'll just, you know, it'd be kind of nice. Oh, but this is another thing. Because messing around with your shaders and notice objects vanish when you zoom in too close, but not grant shaders. Any idea why? The reason why is that I should probably learn how to use bookmarks. Remove. Is it here? Normally, the projection matrix defines a frustum, which is defined by a near and far plane and then sideways planes. So it looks like this. And if something gets too close to the camera or too far away, it gets cut off because it's not inside this frustum. Grant did something to make this not happen. I guess it is possible. You could just put the near plane right on top of the camera. And you could put the far plane like super far away. The only reason this is really done this way, well, there's two reasons. The main reason is to save on rendering time. If it's something that you don't want to see anyway. And another reason is that it can cause glitching if you have objects that are really far away and really close at the same time. Okay, I can't find a picture here, but you get the idea. It's a shape that looks like this. May sometimes I'm vanishing with ground shooters, but it's less frequent. Yeah, that could be anything. Ground shooters are super complicated. Another thing though, if you edit these near and far, I think it changes how much of the scene is shown. So let me... Okay, so I guess that's running. And if I go to utils OpenGL, I go here, here's where I have that near and far plane, and I have it just set to 2 and 30. Which is probably pretty reasonable. If you're getting like that close, do you really even want to see it? But anyway, if I put this maybe to 1, I guess, that might distort the image. Yeah, so now, like, you see less of the image. Wait, why did it do that? Oh, wait. Something crashed with my updater thing. Oh yeah, that shouldn't be a list. But changing that near and far plane, yeah, it does this. So what I ended up doing But now you can zoom in closer before things start disappearing. What I ended up doing is just setting them to things that seemed pretty good. I think you can actually increase the far plane, and I don't know if any distortion will happen. Yeah. But, that's why. One day, that'll probably be configurable. Maybe. Alright, so let's add an update. Let's do self.camera. I'll shift the camera. Oh, that's not how you do an updater. This will take a... I guess it won't take a mobject, it'll just take the time. Because otherwise you would add it to the mobject, right? So I guess what I'll do here is self.camera.model matrix equals itself at OpenGL.translation matrix x equals a little bit. What this should do is shift the camera. And it's not doing that because I'm not passing DT. Okay, now it's doing that. Also, I think the rotation does some weird stuff when the camera's shifted. Not sure why that is. Or is it? Maybe this is... Yeah, anyway, I think there's something up with that. But what I want to do isn't to actually translate this. I want to update its spherical coordinates to make it rotate around in a circle. So what I could do is move its position, then try to turn it so that it's looking at the origin again. Actually, maybe I can just... Let me try this. If I just do rotation matrix and I go around the z-axis, 0.1 times... Yeah, just 0.1. Interesting. Though I think that makes sense. Wait, does it? Yeah, I think it does. What I might be able to do, if I could add the camera to an object 3D. I said like origin point or something. I don't even know if object 3Ds work. Like, work on this branch. I did it on my tutorial branch, but I haven't brought them over before. And I'll add it to this. Make sure that doesn't break anything. And I guess it does. Child.parent is not none. I guess just have a parent attribute, but do mobjects not have parent attributes by default? So here it's from OpenGL mobject. Maybe it's something with meshes. No, it's not showing me the class. Do these have a parent? No dot parent. Object 3Ds have a parent. Oh, so eventually I would want this to happen. I could have sworn objects had parent pointers though. If I go into OpenGL Mobject. Parents. I don't know how I feel about this idea that mobjects can have multiple parents. Actually, I probably will have to change that at some point. But that's going to be probably pretty annoying to change. But okay. Maybe we can have the parents and have a parent separately. Because in order to have hierarchical model matrices, it'll need one parent. So I'll do that, see if this helps. Okay. So that didn't break anything. And now what I'll do is update the model matrix of the origin point. Wait, there's no way this works. I don't think. So I don't think I've set up the logic for hierarchical, yeah. I haven't set up the logic for hierarchical model matrices yet. Darn. So I might have to do this by hand. What a pain. But I think the math will be a little easier. I wonder if Grant wrote any functions for spherical coordinates. Man, my Vim is going slow. Can we get it together here? I think it's still going slow. I did an update a while ago that like slowed it down a lot. Move camera. Animates the movement of the camera to the given spherical coordinates. I feel like that does too much. Converts from spherical coordinates to Cartesian. Why is this just called funk? Oh, there's only a specific thing for cone. Okay, so I'll move this to space ops. Might just call it Cartesian to spherical. Or, yeah, Cartesian to spherical. And, oh, this is going the other way. This is going... Actually, this isn't even going to help me because this is only U and V. Yeah, it's doing the other way around, but it's only doing two-dimensional, so this is super not useful. Daryl Golden, what's going on? Okay. Time for Wikipedia. Or, I can't believe I just put in spherical, like it would just know what I was talking about. Where did that go? Here we go. Okay, here's Cartesian spherical. This will take X, Y, Z. Blake 4096, what's going on? Oh, we got that problem. This problem of getting the letters to always face. Difference between Windows and Linux fonts. Interesting. I don't use Windows enough to tell. The geometry was really crazy. I'm actually kind of proud of myself that I figured it out. This is just the norm of this vector, right? Actually, this should be a vector, shouldn't it? Change the formula. If you mean by change the function to do that transformation, I did end up doing that. I think this should just be a vector. Then it can give back a vector that's r theta phi. Or maybe it should be a tuple, I don't know. That probably wouldn't be super intuitive as a vector. But r equals that. Theta. I'm gonna switch to the Linux, but the fonts bugged me. Oh yeah! Some websites have really bad fonts for me. Usually ones that are like pretty basic HTML. I thought this one would have it. No, this one doesn't have it. But if I go to like OpenGL documentation or something. Even this doesn't look that bad for some reason. Okay, but there are some sites where the fonts just like totally lose their minds and it's really bad. And it's not that easy to get them set up correctly, unfortunately. This looks like Z divided by that norm. What's the arc cosine Z over R? Okay, I can just do that. For arc tangent, well, I already have this norm. So I'll just do that. B equals arc tangent Y over X. Oh. Yeah, good times. Good times. Great, that wasn't so hard. And here I'll take an R theta phi. And this can just be, well, I could actually cache the sine theta. Well, let's see, I need cosine and sine of phi and cosine and sine of theta. 1, 2, 3, 4. I'd be saving one sine. Is it worth it? Probably not. I'm just gonna put the formula here. R sine phi sine theta and R cosine theta. Make sure I got this right. R cosine phi sine theta. R sine phi sine theta. And R cosine theta. Great. So with that, what I'm going to want to do is in this updater, this won't work. Move the camera to the spherical coordinates by incrementing like phi. Yeah. So I should say r beta phi self dot camera dot get position. So this is the camera's vector. And what I'm going to do is pass that to Cartesian to spherical. Okay. Then I'm going to want to increment phi. It's phi plus... We could just do phi plus equals whatever. 0.05. Then get the position back. So we spherical to Cartesian. Now the star. No, I don't have to do star, it'll just be r beta phi. Then I'm going to move the camera there, which I'm not totally sure if I can move the camera to a specific place, at least with a simple function. Get position. There's actually, oh, there's already an set phi. I just don't trust it because Grant wrote it. Oh, this is for Euler angles. This is a different phi, I think. It doesn't have an R. But get position. I think I want to set this part of the matrix. Close that. A lot of these I can close. This part of the matrix represents the position. So then we can do self.camera model matrix indexed here equals new pause. Maybe. Oh, that didn't work. Oh, I'm dividing by 0. In long scalars. And this actually makes sense because I'm starting it with right on top of the z-axis. Which means the x-coordinate is 0. Let's see, r will still work. Theta should just be 0. Yeah, I think theta is safe. I had to do a few checks. If the norm equals 0, then what? I have to return 0, 0, 0. Okay, so I do that. Now I have the norm. So I can divide by this safely. then x equals 0 for phi. So let's see, if vec at 0, if this is 0, and phi is, I'll just put it at 0. So let's see if that works any better. Interesting. So not quite. Spherical to Cartesian. I wonder why it's jumping like that. What I want to do, let me just set the camera somewhere else in the first place. Like when I start out, I want this to be spherical to Cartesian of like 4 pi over 4, and then I'll just do 0. And I won't do this updater. No, it's not even setting the position by default. Well, that's annoying. Let me see what the model matrix is after this. Oh, it's... Wait, what? 202. That isn't what's reflected here. Wait. It should be passing the view matrix from this camera in the OpenGL renderer. Render object. Is that happening? That must be happening. If I go here, camera.projection matrix. Yeah, camera.get view matrix here. Which will invert the model matrix. So why does it seem like this isn't doing anything? I wonder if this updates the vector or updates the matrix. It must though, right? I wonder if I have to use that default position variable. There was a time when I had like a default camera position. Well, that's annoying. Somewhere this has to be getting reset, I think. Actually, I think it's something in interactive embed. Here, camera.model matrix is self.camera.default model matrix. I don't think I want to do this. Because if I wanted to set a default model matrix, why wouldn't I just set one in the scene? like that. So maybe that... Okay. That did in fact change it. But now all the rotation logic was screwed up. Man, I wish the rotation logic was more polished. That would have been so nice. But let me try to put this at like 600. This should be about the same place that it was, which I think it is. I actually don't know where it is by default. Wait. Yeah, by default it's just a pretty good place. 006? I just set it to 11, I guess. Okay. So I go here, move this to 1100. This should be the exact same place. And that's not what I want. What I want is to have a little bit of theta. So I'll put pi over 4 here. And it worked. It moved it, phi was 0, and it incremented theta, and so it ended up looking at the x. However, the camera wasn't rotated to look at the origin again. And to do that, I think I got to do some spherical coordinate stuff. Because now there's like, it's not focused on the origin, so all the rotation logic is like off. Well, better get to it. So I think what I want is luckily the camera has a model matrix, so this will be a little bit easier to do. But if the origin is like somewhere, and that's the z-axis, and the camera is looking from here. Well, the camera's position is here. What's currently happening is the camera is still facing straight down. Straight down as if it was here, because this is where it starts by default. So I want to edit this so that the cameras, it looks in the negative z direction. And I'm pretty sure this is the y direction. So if it's looking like this, straight down, that's the negative z. And that's the y. Then I want to rotate it out around a vector like this. I want to rotate it so that negative z is pointing at the origin. And I think that's it. Is that it? Well, negative z is pointing at the origin, and y, this y vector has to be pointing also toward the origin, but after I project it, I think. Because because otherwise it'd be looking at the origin, but it would be tilted. But how would I really do that? I guess the x vector? Okay, here the x vector is going into the screen. How to ensure that the y vector is like pointing toward the origin? Well, I guess when I project the y vector onto the xy plane, which will be here. So this is the projected y vector. This should be pointing toward the origin. So I think that'll do it. I'm using the quaternion interpolation to move the camera. I am not, actually. I should probably do that at some point. The integration, all of the tools to like position things in 3D aren't very good. There aren't many ways to do it. Unfortunately. Eventually we should get to where things like rotating with spherical coordinates should just be like one function. But we're not there yet. Also, I'm gonna need to look at this. Probably. It's a pain to work with. Yeah, it doesn't help that the tools to do it aren't very developed. And the ones that there are like in between 3D and 2D. It's just all super new. Okay, first things first. Let's get the camera. I need a vector from the camera to the origin. And this is just self.camera.get position negative. So that's camera to the origin. The interactive scene is a nice step, so you don't have to fiddle with the camera as much, but instantiating objects takes forever. True. Super true. Okay, this is the camera to the origin. Then I can get the negative z vector. Camera facing. Camera front direction. And this will be the negative z vector. Model matrix at 2. Okay, so it's all rows. Second column. Wait, it's not all rows. It should be like this, I think. Right? Model matrix. 0, 1, 2 rows in the second column. I just print that. This should be just a negative z vector. And it is, I think. And I'm going to want to rotate this so that it points at this. And I do this a lot, actually. There are a lot of times where I'm rotating a vector to look at another vector. I should probably factor that into something at some point. But basically every time I do this. Character origin. This will be camera to origin. Front direction. This will be that too. So that'll give you the angle between those. Now I can cross these. Oh, wait. Camera to origin. Cross these, and I want that to face where? I don't think it matters, actually. Oh, I actually don't even know the sign of this. As usual. I'll need a normal vector for that. But I guess I can get the normal vector just by crossing these. Like the rotation axis. Just be the cross product. So now I can sign it based on the direction of that, I think. Then I want to rotate the model matrix. So I can get the rotation matrix. So take angle and then the axis. Rotation axis. I'll multiply this by the sine. And then the camera's model matrix, I'll multiply hopefully by this rotation matrix. And now, if I'm lucky, the camera will be pointing at the origin. Or I'll get an error. What? Oh, this is a 3x3. Well, let's see if this works. And I don't see anything. Darn. Although, shouldn't this multiplication be on the other side? Because it isn't... Because it's formatted like a regular matrix? Okay, well it's looking... It looks like it's looking in the right direction. Well, it's rotating in the right way, but it's facing the wrong direction. So I think this sign needs to be reversed. Nope, that didn't help. Weird. It should be the angle, and I'm just going in the other direction. Pi over 4. Let me just rotate it by pi over 4. Like negative pi over 4. Still no. Do positive pi over 4. That's what it's doing before. What axis is this rotating around? Okay, I gotta do pi over 4 plus like epsilon. So it rotated further toward the x-axis. So it does look like this needs to be negative. What if I made this a 6? Okay, I have no idea what it's doing now. I wonder if something's wrong with my math here. The rotation axis, camera to origin in the camera front direction. Ran out of space on your external hard drive. That sounds really difficult. But you did it. Oh, I think I see what the problem was with this. If I move this in the negative y direction, so I guess this would be negative pi over 2? I really hate when the math gets this complicated without being able to see anything. Close. I think that's close. System error. Yeah, that sounds reasonable. Okay, I got to make sure my math is more correct. E-noise for research. Interesting. Best of luck. Okay, all we know in this situation, we have the origin, the z-axis, obviously. The camera is pointing in a totally wrong direction. Doesn't matter where. But it's pointing in the camera's negative z direction. And that's all we know. I can compute this vector. That's not hard. Then it should be just a matter of rotating this. And this is the negative camera vector. And this is the camera's negative z vector. And then it should be looking at the origin. Let's see. I'm gonna try that again. Okay, so this is positioning the camera. Camera to origin. Take the camera's position vector. And I just negate that. The camera's front direction. This should be, at this point, it should be pointing straight down. And it is at that point of the code. Okay, then I'm gonna cross these. And when I cross these, what do I expect? Well, in this picture, which this isn't drawn accurately because the z vector is going straight down. If I cross the camera to origin vector and then the camera front direction, I'll get something pointing out of the screen. And since phi is negative pi over 2, this angle oh wait, this is getting complicated. Negative z this this would be the negative y-axis. And this would be the positive y-axis. When you cross x and y, you have to get z, which means the x-axis here would have to be going into the page. That's the x-axis. So when I cross the camera to origin vector and the camera front direction vector, I expect to get something in the negative x direction. Okay, so let's write that rotation axis. And it is, great. I guess you can't see that, but it's in the negative x direction after all. It isn't normalized, which might be important. Maybe there's a better place I can put this. One day I'll have a good stream. If I feel like it. Okay. So this is pointing in the negative x direction, which is what I expect. Then I get the angle between those, camera to origin and the camera front direction, which is this angle. That's theta. The sine of this. I don't know the sine of this. Well, actually I do, right? To get this vector, the rotation axis, I crossed the camera to origin vector with the camera front direction. So that means the positive direction is this way. This is the positive theta. So when I get this rotation matrix around that rotation axis, I'm going to want to rotate the camera's model matrix in the negative direction. I don't think I need this sign. I think this is -1. So I'll multiply the camera vector, or the camera's entire coordinate space, by the rotation matrix, defined by a negative angle and that rotation axis. And it's homogeneous. Okay, so... and nothing. If I zoom out, still nothing. Darn. Well... I tried. Even here. This is where I expected, even. And I'm rotating around the negative x-axis. That's pointing that way. And I'm rotating by a negative angle. What could possibly be going wrong here? If this angle is negative, I'd be pretty mad. It's not, thank goodness. 0.7 radians. And that seems right too. All of this seems right. I'm gonna try rotating this by just a smaller amount. That's rotating by negative 0.1, 0.2, 0.3. Wait, why is nothing changing? Oh, because I'm not multiplying it there. That'll do it. Okay, so I'm going to split this back to 0. Okay, that's 0. Negative 0.1. Already off the screen. Positive 0.1? Wait, that's just leaving it where it was. Didn't like something I did. This is positive 0.1. Positive 0.2 is already... It's not live updating or something. That would have made it too easy. If I could just live update this. 0.2 sees a little bit more. I think that's a little bit more. But why isn't it pointing toward the origin? Okay, I'm gonna have to set this to like 0.1. And then do this in an updater. I'll do update camera. And multiply by this rotation matrix. And hopefully that way I'll be able to see what this matrix is doing. 11.01. Also, I should make this so that I can optionally take the time. That's weird. Where would it have to be for that to appear like that? Does the rotation matrix affect the position? It does. Wait, does it? Yeah, it does. This is 0, but these are changing. I don't know why they would be. Oh, I think I know what I have to do. I think I have to translate this to the origin and then rotate it and then translate it back. Yeah. Also, this is a space ops rotation matrix. Is that even what I want? I can just get a rotation matrix from here. Oh, but this doesn't take an axis. this takes XYZ. So what I want to do is OpenGL that translation matrix. I want the negative of the camera's position. And hopefully I can star that. Then rotate it and then bring it back. Hopefully. Okay, now it's at least staying in the same place. Though it's still not rotating so that it sees the origin, so that it looks at the origin. Oh, it did. It did. Great. It just took a long time. So... maybe I can do this here now, outside of the updater. Do it the proper way, like that. This will be the negative angle. Okay. I did it. It's looking at the origin. Oh, that's why I had that default position. So that when I pushed R, it would go to the default position. That was a lot of math for something pretty simple, comparatively. Okay, so I can just make that the negative angle. Okay. So what do I want to do with that? Firstly, I think I do want to change this. Okay, I don't want that there. The camera default position. Yeah, let me put that back. Camera.model matrix, self.camera.default model matrix, yeah. Then I'll put self.camera.default model matrix equals this. Wait, let me just update the camera's model matrix. And here I'll do self.camera.default model matrix. Equals the model matrix. Great. Now I come back here. It's looking at the origin from those spherical coordinates. And when I press R, it comes back to that position. Never mind that the Z and I think the X are reversed. We will deal with that later. Wait, here it's right. But if I press R... Wait, it's right again. Okay. Oh, it's if I do it from like over here. And the Z switches places. And the Y too. Which I think almost makes sense. No, I don't know why that would happen, but okay. have an idea why that would happen, but fixing it would require giving those mobjects an actual model matrix. Okay. So now I can do what I was trying to do, which is make it ambient rotate about the phi to increase its phi position and have it keep looking back at the origin. However, all of this code, I think I'll have to like factor out. Crack open a textbook so I can follow along. Okay, I want to think, I'd like to think that this is something that can be taught without a textbook, but I don't think that's true. This is like pretty intense math it's becoming. Yeah, but if you wanted to read something to explain a lot of it, this would be a good resource. Okay. Yeah, I don't think this will actually be enough. It's only in this case it happened to be enough. But it could be the case that even if the camera is looking at the right point, the origin, it could be rotated so that it's looking at it with like a tilted frame. And how would I fix that? It's like the same problem I was thinking of before. Okay, for now, I'm just gonna make it point at the origin on each frame. Which means I'll basically do this. Do this on each frame. So let's see if that's all I need. Oh, I didn't add the updater. Yeah, now it's always looking at the origin. Even when the logic is set up so that it doesn't think it's looking at the origin. Which is causing the controls to be weird. Getting all these controls to work correctly, I wonder if there's a better way to do that. There probably is. But okay, that did do what I expected it to do. Now, I want to increase the phi value, so do this. Okay. Well, that's not doing what I expected it to. What is it doing? Interesting. Oh wait, is that expected? That might be expected. Because the camera's slowly turning upside down. which means it is pointing at the origin with a tilted frame. At least part of what it's doing. So this is rotate the camera so that it points toward the origin. And after that, oh, and I should be updating the default model matrix here. Let's take that line out. What I should have to do now is rotate the camera so that it's right side up, whatever that means. Because what I'll have to do is this. Okay, camera is looking at the origin. We have that much, so origin, camera, it's now looking at the origin. However, the Y vector for the camera may not be pointing toward the origin. So the camera frame could be where this is the origin and this is the camera frame. So the next thing to do is rotate it so that the camera's Y vector, which is pointing like this, I think. This is negative Z. You cross X and Y, you have to get Z. So X is like this. This is the positive Z direction. Okay, so yeah, that's the Y. And here is the Z-axis. So I need to rotate the camera so that its Y vector is aligned with the Z-axis. This might not be so hard after all. What I have to do is project. Actually, it might be sort of hard. Would I guess project the Z-axis onto this plane and then just rotate it. And just rotate it like that. So project the Z-axis onto this plane. And this is the global Z-axis. And I think I just have to rotate it so that it aligned. I think that's it. I think. Let's hope. Honestly, this is enough work that maybe I should just be implementing hierarchical model matrices. Would that even make this easier? No, yeah, it totally would. Because, yeah, it definitely would. So I should probably start implementing that next. Man, this is ending up being so much work. But I'll do this for now. I'm gonna project the Z-axis onto the main defined YB. Cameras position vector. So projecting, I would take the Z-axis, which is out, Now I subtract the projection onto the normal vector. So it's going to be a dot product out and that normal vector, which is the camera's position. I'll have to normalize that. I actually need to normalize it here. Oh no, not there. But here. So based on how it's normalized this, then I can dot the out with the normalized vector. And multiply by that normalized vector. Great. And there's nothing to divide by because it's a unit vector. Now I have this projected z vector. Now I'm gonna want to multiply. I'm gonna want to rotate the camera so that the y-axis is aligned with the projected z-axis. So it'll be like this. Just gonna rotate the camera so that it's y-axis with the z-axis. So the two vectors are first the camera's y, so that's gonna be self.camera dot model matrix index all rows up to 3. Wait, camera y vector. Rows up to 3, column 2. No, 1. That's the camera y vector. Then I have the z-axis is out. The rotation axis is going to be the camera y vec. I'll cross that with out. Okay, that's going to define a positive direction for the angle, which will be in that direction, which is actually not what I want, I think. If I do z cross y, then this will be the positive direction. So we do that. So now I'm gonna get this angle. Out, camera y vec, and the y vec. That gets me the angle. And the rotation matrix. Alright, I want the negative angle. This is the positive direction. I want to do the negative to bring the y to the camera. Rotation axis homogeneous equals true, and then... Oh wait, I wanted the projected z-axis. Not the regulated z-axis. There we go. Alright, so this is projecting the z-axis onto the camera's position unit vector. Great. This is getting the camera's y, rotation axis. Okay, now I want to multiply, or I want to do this basically. So translate it, rotate it, translate it back. And I have zero faith that this would work. Oh my gosh, it's working! But why is that happening with the mesh? And also, why is the Z turning? Wait, what in the world? I'm actually so confused. The X is jumping back and forth. Why would everything flip like that? Why? Also, it's going way too fast. I don't get why that would happen. And it's still going too fast for like ambient rotation. I think that's a little bit more ambient. But it's too bad the mesh freaks out like that. And why would it? Because it doesn't do that when I drag, I don't think. I just... wait, hold on. Something's still being updated. Where? I just dragged the mouse. That doesn't happen. But if I do it in the updater, then it does do something weird. This is from updating the camera's model matrix. I guess that would make sense, since the camera's model matrix is passed to everything. Let me see the way it happens in the dragging logic. It's rotation off of the z-axis. Where's the rotation around the z-axis? Point. There's D point at 0. There's D point at 1. Oh, I do want the right click drag. Oh no, I want the left click drag. What am I thinking? Here? It's doing the same thing, just getting a rotation matrix and multiplying that. Yeah, that's just multiplying that by the model matrix. It's so weird that something about this would swap the directions on all the objects. Maybe it's because I'm doing these separately? Probably not. But it could be the case that doing these separately causes some sort of problem with the rotation. And this happens every 180 degrees. Weird. Let me print out the camera's model matrix. Are any of these increasing forever? No, it looks like they're not. Maybe this has a problem with having negative values in the model matrix. I don't totally see why it would. But I think these jumps occur at places where some of the values switch from negative to positive. Oh, it's where some of these values loop around, I think. But this doesn't happen when I drag. I think I'm gonna try doing this all at once. I think. Well, no, I actually can't. Yeah, because I have to do the first operation to do the second. Man, I feel like this is gonna be hard to debug. Unfortunately. What would it be that swaps everything across? It swaps the X values and it swaps the Y values. The only thing that isn't swapped is the Z values, I guess. I can see it happens when some of these values flip over to being positive from negative. But that's pretty much all I can see. Maybe I should just defer to the logic from the orbit controls. Potential camera model matrix. It's just a rotation matrix. So here, translate to the origin. Oh, here I'm recreating the model matrix on each frame, rather than multiplying it to update it. Can I do that? Rotate the camera so that it points toward the origin. So rather than rotating the camera, I can just get the matrix, which would point it toward the origin. Would that work, though? How do I do it here? I did a translation to the point and then a rotation. And then presumably a translation back later on. Let's see. Oh no, I took the model matrix, translated it, then rotated it. Which is fine. I doubt it'll make any difference, but I'm gonna do this in line. So translate, rotate, and then translate again. So this is doing effectively the same thing. And reality is still shifting every time. I wonder if this is a common OpenGL thing. Well, I guess the phi. Can we print phi? Maybe this happens when phi gets too large. What happens when phi switches sign? Maybe that's all it is. Let me not print this. Print either of those. When phi switches from positive to negative, that's when this happens. Wait. There, phi just switched. Again, phi switched positive to negative. It can switch negative to positive and there's no problem. So I guess I want to keep phi in the range from negative pi over 2 to... I can't tell. Slow it down. Okay, that's 0. Now I wish it was faster. From 0 to... It's gonna be pi over 2. 0 to pi over 2. Okay. But that's only part of it. Okay, let me make that faster. 0 to pi over 2 is okay. All of these numbers aren't okay. And then negative pi over 2 to 0. So it has to be from negative pi over 2 to positive pi over 2. But that's not enough, because that doesn't fill out the full circle. Man, that's annoying. I wonder if it's something with a conversion. Yeah, I don't know. Could I possibly have had a bug in this? R cosine phi sine theta. R theta phi. Then this is R theta phi, and this is R theta phi. R cosine phi sine theta. R sine phi sine theta. And R cosine theta. Now it's all right. Maybe I can make phi always positive? And maybe that'll help? What does Python do if I do a negative number? Like negative, oh. Negative 3 mod 10. 0 mod 10. So if I just take this, 5 plus this, mod 2 pi? So now it'll always be from 0 to 2 pi. Guess that's worth a try. It switched immediately. Yeah, it still does it. This is when it switches across pi over 2. It switches across pi, I guess. Maybe I want to negative pi to positive pi, something like that. So I do this minus pi. Yeah, I didn't think that would work. Yeah, same thing. Well, that is unfortunate. But I'm gonna probably have to debug more to see why this is happening. Okay. Well, I'm gonna have to debug that some. It's been around 2 hours, so I'm gonna call it here. And probably debug this for 4 hours. So, thanks for watching, everyone.